Hello, my name's Carol Petersen. I'm a pharmacist. I've been involved with compounding bioidentical hormones for 27 years now, and I also am certified in nutrition. The topic I chose to cover today is about the myths that we embrace, and it becomes part of our treatments and therapies, and in the end, we don't even know where some of this came from and why, and what was the evidence. And so I wanted to share with you a few of the things that have given me cause for concern that I know has been embedded into our culture, into our hormone culture. So as I was looking for the roots of these, I went back to Dr. John Lee. We have a lot to think about. He pioneered looking at natural progesterone or bioidentical progesterone. He published a study using progesterone in osteoporosis. He was a very avid spokesperson about progesterone, and he really gave the whole idea of bioidentical hormone therapies a big boost. However, he said a few things that I still run into. So here's the question: how much progesterone does our body actually produce? And Dr. Lee pretty much told us that we only produce about 20 milligrams in that. So he's saying usual dose, 15 to 24 milligrams, cycling for premenopausal women, and then postmenopausal, 15 milligrams. And he recommended creams which would deliver that, and a 1/4 teaspoon dose would deliver about 20 milligrams per day. Where did he get this? I looked high and low, up and down. I have no evidence that this 20 milligrams means anything. Here we go again. This makes me a bit crazy. Fat storage of hormones. This is also commonly heard. I'm surprised how much I hear it. I see it in even books written by other authors. Where do you get this idea that there is actually fat storage of hormones? And who has done the biopsies of the fat to show that this is actually occurring? Can't find it. Nobody gives me a source. John Lee is our source. He is the one who said this. So here it is. He believes at this time, and this is a long time ago, we're talking 25 years ago, that fat storage of hormones was a big deal. I worked briefly for a professor at the pharmacy school at the University of Wisconsin, and he was the person who developed progesterone in the vaginal product Hormone. And he said that there is no fat storage of hormones in the skin. The only thing that limited the absorption of hormones was the stratum corneum. Once it's through there, it goes into your bloodstream. So here we go. I don't know what else to say about that, but no fat storage in the fat cells of the skin. This was Dr. Joe Robinson. He also specialized in studying the skin and eyes. So I would take this fat storage with a grain of salt, and here is where it came from. Where to rub your progesterone. John Lee also gave us a strategy for using progesterone creams and to rotate the areas, because he said you're going to saturate any one area and you're going to saturate receptors in that area. So this idea came from him too, and still carried on. Often people are told to rotate. After searching PubMed, American Chemical Society, National Academy of Sciences, looking for anything to help explain these things, I gave up. And I went to Dr. Ray Peat. Dr. Ray Peat was also a huge pioneer in this area. He is one of the people who put together and studied as a biochemist the use of progesterone and for the many uses that progesterone has. And John Lee was inspired by Dr. Peat, and Dr. Peat is, for many years, was still an avid researcher, and to this day, he has a very, very interesting newsletter. So I wrote him, and I love this. John Lee usually just said what sounded plausible to him, and about the progesterone receptors being too full. I covered that. The uterine vein study indicated there was over 100 milligrams per day of progesterone being produced. And this is the study he provided for me to say that. So we have progesterone being produced all over the place. And this is the question: how do we have a number on how much progesterone the body uses and needs and makes? We don't have a number. And I'd like to share with you a few things. So progesterone is not just formed by the adrenal glands and the uterus and the testes. It's made in all sorts of areas of the body. And one of the prime areas is throughout the nervous system. And all the Schwann cells produce both progesterone and pregnenolone. And most of that production is used right there. And here's something I just came across that blew my mind. I was noticing that there was increasing number of people lecturing about mast cells, and to my amazement, mast cells have huge number of receptors for estrogens, progesterone, testosterone, hydrocortisone, even thyroid. And so this is a big deal. People have mast cell oversecretion of histamine and violent reactions sometimes. And the really interesting thing is the relationship of mast cells and estrogen. There are a lot of estrogen receptors, and progesterone is really needed because estrogen tends to make you more likely to be releasing histamine from mast cells. And that's not surprising. We see with estrogen products, things like asthma tend to be a common side effect with estrogen. Progesterone inhibits that mast cell secretion. And what's really, really interesting to me is the amount of progesterone needed to do that was an amount that are found in early pregnancy. When I first started in this field, we were using progesterone for PMS. The starting doses of progesterone were 100 milligrams 4 times a day during the luteal phase, going up from there to control the symptoms. To my surprise, I found out that PMS can just as well be a symptom of mast cell degranulation. So progesterone may have been treating mast cells when we started 30 years ago, and we had no idea this was part of the problem. We just didn't know. And here's another thing about hormones. Inside your cells, your body has all the enzymes needed to make all of the sex steroids right inside your cells. And we do not have a way of independent measuring. This is endocrinology. I thought I would expand on this a little bit, but you can read this slide at your own leisure. I'm not going to read it to you. Endocrinology really puts a whole different slant on things. We're so used to the idea that only certain organs produce hormones, and from that production and the flow through our bloodstreams, those hormones get to where they're going. And now we know that hormones are produced all over the place. Different tissues and different cells will produce it at different amounts. I really like Stephen King's book on neurosteroids, and the takeaway I got from that was how little we really understand what's going on in our brain and the production of hormones. As I said, with the Schwann cells for the nervous system tissue, the brain is capable of producing all the sex hormones, all the enzymes, precursors, everything is there. However, there's some interesting things about hormones in the brain. Different parts of the brain, according to Stephen King, will produce different amounts of hormones in different parts of the brain, and different concentrations, higher or lower, can have equal and or opposite effects. So it's very complicated, but they're there. Allopregnenolone, for instance, according to Dr. King, concentrates in nervous system tissue at 50 times the plasma levels. And then it's used right there in the nervous system tissue. Spinal cord neurons contain progesterone, pregnenolone far in excess of the serum. And then on top of that, all our emotional states can cause all sorts of changes with the amount of neurosteroids that we make. So my point is that we don't make 20 milligrams of progesterone a day. Hormones do not store in fat tissue. Receptors don't get overburdened by where you put the hormones. And we still have so much to learn about hormones. It's a never-ending story as we drill down into these rabbit holes. So let me continue down. Here's another myth. Everybody will be very familiar with this chart, looking at the cycling of the sex hormones in the female. And look, for example, that black line, that's progesterone, and compare it to estradiol, which makes you think that progesterone levels are pretty much on par with estradiol. This kind of chart is reproduced in books, put up on slides all the time. But there's a big piece missing, and the piece is, you'll notice there's no indication of what units those graph lines are supposed to be showing you. But here you are. I got this from LabCorp. So on the left is progesterone, normal female levels, and on the right is estradiol. And the interesting thing is the left is in nanograms per milliliter for progesterone. The right is estradiol in picograms per milliliter. In order to compare the numbers, you have to multiply the numbers on the left by 1,000. So if you go back and look at the graph, that black line for progesterone needs to be 1,000 times greater than the estradiol. So progesterone is so fundamentally important, and we lose some of that information. The other thing that often happens when you have a chart like this is the follicular phase progesterone is completely disregarded. But look at it again. Imagine it 1,000 times greater. Follicular phase progesterone comes from the adrenal glands primarily, but you also can get estrogen, as I mentioned before, from all sorts of tissues and cells. So there is a lot more progesterone in our bodies, and this chart is responsible for a lot of misunderstanding about relative amounts of hormones in your body. Here's another one. This is from Dr. Jerry Lynn Pryor, and she has a fabulous foundation called SEMCOR, Center for Menstrual and Ovarian Research. And she has been publishing many, many years for this, looking at the female cycle. And one of the more startling things she's learned is that when women go into perimenopause, unlike the prevailing attitudes, women at that stage in their life, and she's found in his research, and she's published this, have the highest estrogen levels of their whole lifespan. Then combine that with, we're starting to, in perimenopause, starting to miss ovulations. If you can keep the chart back in your mind, the ovulation is where we had peak progesterone levels created by the corpus luteum. However, if that is not happening, all we have is a follicular level throughout the whole cycle. We've lost that lovely big surge of hormones. And so in contrast to the highest estrogen we've ever had in our lives, we have the lowest progesterone. And during this perimenopausal time, I'm just appalled at how I see the majority of women being treated. It is unbelievable how many women, as soon as they have sleep disturbances, as soon as they have trouble with their breasts, memory issues, and they're having heavy bleeding, all estrogen symptoms, their doctors are saying, oh, you're perimenopausal, we'll start you on estrogen. And this is so appalling. One of the biggest problems facing these women is heavy flow. Heavy flow, so much that they're happy to submit to hysterectomy. We do 700,000 hysterectomies in the US yearly, and a lot of these are simply because women are mistreated. They need more progesterone than ever, and they have less. So this is not happening. I'd like to actually go back to my slide here and look at the curve for progesterone again. And we also have this belief system that progesterone must drop to bring on menses. And it would look like this is a reasonable conclusion from this slide. And I have to go back to the years I spent with PMS treatments with progesterone and large doses of progesterone, like I said, 400 milligrams and maybe more. And the women with the worst symptoms of PMS often continue to have symptoms into the follicular phase time, days 1, 2, and 3. And their progesterone levels never dropped, and their cycles were always very regular, these younger women. And so I would like to submit to you, it's maybe not so linear an idea as up and down. I would submit to you a hypothesis that the area under the curve is what is important for menses to occur, more calculus. I had read a study once where women were supplemented with progesterone in the luteal phase only, and they were given 100 milligrams of progesterone twice a day, 200 milligrams of progesterone twice a day, and then one protocol with 300 milligrams. The 200 milligram per dose women did not bleed. The 300 milligram per dose women occasionally bled, and only with the 400 milligram of progesterone bled regularly on that protocol. So they were indeed supplementing the luteal phase, and it's my belief or my hypothesis that there has to be enough accumulative progesterone effect to allow those cells to become secretory and bleeding start. Here's another one. Does avoiding the first pass effect protect the liver? And I can't really say how many people are confused about what that first pass is doing. And what happens for the first pass is if you give a drug, any sort of drug, and you give it orally, both the gut and the liver will reduce the dose before it gets into the bloodstream. So avoiding the first pass by any of these other ways to use any drug intravenously, intramuscular, sublingually, transdermally, avoids going to the liver directly. What protects the liver is actually the nature of what you put in. If you use foreign hormones topically, you're not protecting the liver. The protection for the liver comes from the nature of the hormone. It's something that your liver recognizes and able to handle and metabolize, has proper enzymes for. So according to Cleveland Clinic, how long does it take for the blood to circulate through your vascular system? And as I said before, if you put something on transdermally to avoid the first pass, how long before it gets to your liver that your body would have made a complete pass? And people don't usually think about this, but here we go. Only 20 seconds is needed for your blood to circulate your entire body. So when you use something transvaginally, transdermally, it will take 20 seconds or maybe less, depending on where you put it, to get to the liver, and it's ready to go into liver circulation and metabolism. So for those 20 seconds, you have more hormone in your bloodstream rather than less. Avoiding the first pass creates more larger levels in the bloodstream. Here is something I thought was really interesting. It's vaginal application. I just mentioned it as a first pass liver avoidance. And this is from a lecture from Dr. Uzi Rice at Women's Hormone Network just last year. And I found a picture to illustrate what he was talking about. So if you want to use hormones vaginally, it makes a great deal of difference where you put the hormones vaginally. So if you use an application and insert a hormone cream or suppository deep into the vagina, those hormones are going to go into general circulation. If the hormones are delivered to the middle area, the circulation takes the hormones to the uterus. And then if you actually need to treat dry and atrophied vaginal tissue, you should apply the hormones to the first 2 inches of the vagina. And then again, if you apply it to the opening of the vaginal area, that absorption from that area also takes hormones throughout your the whole body. So what I'm saying here is vaginal application can mean several different things, and we should be mindful of how we intend to use vaginal application. Here is another issue that has come up, and we have this idea that free hormones are needed to get into our cells, that only free hormones that have somehow escaped the carrier proteins that are in the bloodstream actually get to diffuse into the vascular part of the cell. So we have the free hormone hypothesis. And I'm not sure why we concentrate on testosterone with this free hormone hypothesis, because the carrier proteins do bind to the sex hormones and as a natural sort of their existence in the bloodstream. And we have enormous amounts of hormones that are bound up to the carrier proteins. Well, here is something that has come up, is that the carrier protein, sex hormone binding globulin, does carry hormones into the cell, inside the cell, but it does only if you have this receptor called megalin. And megalin is at the outer complex and will bind the whole complex of sex hormone binding globulin, which might have testosterone, might have estradiol on it, and will carry the whole thing into the cell. So here's a little picture from that very study to illustrate what we mean. So the free hormone theory somehow thinks that on the top, it accidentally diffuses off the sex hormone binding globulin into the into the cell, inside the cell, and then will make its way somehow to the hormone receptor or to an enzyme like 5-alpha reductase and join up with that enzyme for conversion. So this alternative idea with megalin shows that the cell actually engulfs, with the presence of megalin, creates a whole vesicle with megalin and the binding protein and the hormone, and eventually the hormone gets to the same place. But this is a whole new process of intake of hormones into the cell that we had not known for years. So you'll see that it kind of like the cell just bites onto this. So it's an endocytosis. So here's another study. There's quite a lot of studies, and then we have some problem in figuring out how important is this impact. We actually know that if megalin, for some reason, is not available, it does block hormones from getting into the cell, because the clinical presentation of those patients, and there are a few that are genetically unable to make megalin, they will have a clinical picture of being hormone deficient. They're unable to take hormones inside their cells. So this is another thing. We have other carrier proteins like albumin, which we sort of think that the albumin bound hormones somehow diffuse from the capillaries into cells. This is in the case of testosterone, which makes me wonder why testosterone, why nothing else. We look at biologically available testosterone. We include albumin and free testosterone levels. The other thing that makes me really wonder is we have laboratory testing that we say is better because the results are indicative of free hormones. And I'm referring now to saliva testing and to urine testing, which tell us that these hormones are free hormones, not bound hormones. So these hormones are reflective of hormone action inside the body. And now we know that's not necessarily true. Having said all that, do I know what's true? No, I don't. There's so many things to look at. So here's a picture. This is in Boquete in Panama. This is sunrise from the top of Bocan Baru. And so we're just at the sunrise of so many things. I wanted to bring a few things that I believe have gotten embedded in what we think about hormones. And there's still so much research and so many things we can take into consideration. And sometimes we spend too much time in the microscopic. And in order to get some of the answers, and some of the best answers, is the macro. How is this person presenting, and how successful are the treatments that you're using, helping them with their clinical presentation? Thank you so much for your attention. I really appreciate it.